Yeah?
Okay.
Those calculators can send it back to a fraction,
Yeah,
but not with all decimals. That's the thing. It's weird. Yeah, but you can do that. All right. But if it starts as a decimal, if it starts as a decimal, I'm not going to have the fraction equivalent on my paper. So don't make me calculate it halfway through the test and have to stop, because I'm not going to have that on my answer key. All right. I want to finish the has one pet row. So what's going to go in that missing block? 0.14. Okay, what is going to go as the total for the telepathy column? 0.32. Okay, now we have our full table completed. Okay, remember, since this table has a total of 1, that means all of these are already the probabilities calculated. Okay, so what is the probability they have no pets? It is 0.42. No, ma'am. Okay, probabilities are between 0 and 1. So if you say 42%, it's not. It's weird. I want you to write it as a decimal, please. Yes. Yes. This one is a weird one. It has a little typo in it, and I don't know exactly where the typo is. If you go this way, it's 0.42. If you go this way, it's 0.43. But it's because I rounded somewhere weird, and we're just going to do the problem as it is, and it'll be okay. All of your other ones will be exact. This one's just a little wonky. I should have rewritten it, but I forgot about that from last year. So I made a note on my answer key to fix it for next year, though. So probability they chose flying as a superpower. Yep, 0.4. Okay, now the probability of one pet and telepathy. Okay, so one pet and telepathy. So where is that overlap at? Yep.
Would it be wrong if for the flying one we put 0.40?
No, it means the same thing. All right, now we have a conditional probability right there. Okay, so we read that as probability of more than one pet given that they chose invisibility. Okay. So remember, anytime we have a conditional probability, we use the formula for that, okay? So we're going to take the probability of more than one pet and the probability they chose invisibility and divide it by the probability they chose invisibility. So remember, that is us pulling from the conditional probability formula. We just took that and applied it directly to the problem we have. Now, we're going to actually use the chart now. So, what is the probability that it's more than one pet and they chose invisibility? 0.09. What is the probability they chose invisibility? 0.29. Now, what is 0.09 divided by 0.29? Yep. So we're going to have 0.31 as our probability for that conditional probability. All right. Now I want y'all to do the conditional probability for E real quick. Yeah, the next one. Probability no pets and flying. Probability of no pets given they chose flying. So we are calculating the probability they have no pets given they chose flying. What is that probability?
0.55.
0.5. okay? Because the probability of no pets and flying is 0.2, okay? And we got that by looking at has no pets and flying, so we found that intersection. Then we found the probability of flying, which is 0.4, so 0.2 divided by 0.4 is 0.5. Okay, now, we are going to talk about independent events, okay? 2 events are independent. Ooh. If I try to spell independent without singing the song in my head, I can't do it. All right.
Wait, what's the song? No, I don't know what you're talking about.
The song. I'm not doing this. You're doing this on purpose. I'm not doing it. I'm not falling for it.
Can you sing a song?
I'm not singing it.
I don't even know. Is anyone else? No, I
You know what it sounds like. You're just trying to trick me.
I don't know. It's like,
Wait, Miss Meredith, I mean, not Miss Meredith, Miss Dawn, I don't know what you guys
Y'all are annoying.
I don't know. I don't know.
I promise I never heard the Independence song. Yeah, me neither.
I've heard the French song. R-I-E. What? R-I-E.
Please just sing it, Miss Dawn.
No,
Why? Are you nervous?
I don't. There you go. Yeah.
Thank you for showing up.
Do what? Yeah.
I really didn't know what the song was.
When I bought my car, that was like one of the first songs I played because it says she got her own car. And I was like, because I waited till my husband wasn't in there with me, and I was like, that was how I went to work the next day. I was like, I'm proud of myself. I did it. All right. All right. Now, so we are going to talk about independent events. So when we're talking about independent events, okay, it means that knowing whether or not one event has occurred does not affect the other one, okay? So if I take this dice and I roll it, what is the probability I roll a 4?
1 in 6.
I rolled a 4. What's the probability I roll a 6?
Oh. No way, actually. Do it
100%
one more.
apparently.
Okay, what's the probability I roll a 2? I roll a 3. I roll a 5. Okay, it broke. Okay, I was getting a little creeped out. I was getting a little weirded out. Okay, but does the probability change each time I roll the dice?
No.
No. Okay, it's a 1 in 6 every time. Okay, now, so that is an independent event. It does not change each and every time. Okay, now, currently in this cup, there are 2 oranges and 3 whites. What is my probability of picking an orange?
2 out of 5.
2 out of 5, okay? Select dice.
You're gonna get a white.
Ooh, orange, okay? What is my probability of selecting an orange now?
1 out of 4.
1 out of 4, because there's only 4 dice left in here, okay?
Dude,
A white dice, okay? So now, what is the probability of selecting an orange? 1 in 3.
dude, I'm so scared.
Another white dice. What's my probability of selecting orange now?
Why are you playing like
She literally said,
Oh. What is our probability of selecting an orange now? There's another white taken out.
100%.
100%.
Oh my gosh, what are you gonna get?
Oh my gosh, you're
Okay, put 'em back in there. Okay, but that is dependent probability, because each time we take something out of there, it's changing the probability of what we got, right? So, does everybody get the difference of what is independent and what is dependent?
Yes.
Okay, so there are ways to mathematically prove independence, okay? And so we will have to prove whether or not things are independent, okay? And our formulas for that, there's 2 of them. So we have the multiplication way and the conditional probability way. So the multiplication way is where we just take the probability of A, multiply it by the probability of B, and it should equal the probability of A and B if they are independent. Yes. Yes. Okay. If they do not equal, it's not independent, so that means it is dependent. Okay. Now, the other way we could do it is using conditional probability. So we could do the probability of A is equal to the probability of A given B. Or that can be flipped around and say the probability of B is equal to the probability of B given A. Okay? So those are the different formulas we can use. If they are equal, independent. If they are not equal, dependent. Okay? So we have about 6 formulas. And one of them doesn't super count because it's just the probability of an event is a favorable outcome divided by the total outcomes. Okay? These are the things that you have to know for the test. Okay? If you do not have these formulas, that'll be a problem. I'm not giving you the formulas. You have to know them. Okay? The reason for that is the math on this test, right, is adding and subtracting, multiplying and dividing, and dealing with fractions. All of which your calculator does for you. I need to see that you know how to set it up. Thus, I need to see that you know the formulas. Okay, I want you to memorize your formulas. Okay, because I'm not giving them to you. And if on the test you go, what does this mean? And you point to a conditional probability, I'm going to go, well, don't know. Okay, so that is not me being mean. That is, you already can use the calculator for basically everything. I need you to show me you know how to do this, not just plugging it into a formula. Okay, so we're going to do a few of these examples. So I want everybody to flip to question 12. Okay, now, since we're going to be looking at independent events on this page, if you want to, I would suggest putting the formula right here. Okay, so the formula is the probability of A plus the probability of B is equal to the probability of A and B. That's our first formula. That's not plus. That's supposed to be times. That is my bad. Okay. That is the multiplication way to prove it. Okay. The conditional probability way is you have the probability of A is equal to the probability of A given B. Or you can flip that around and do the probability of B is equal to the probability of B given A. These are the exact same formula. They're just written with a different term, with a different event first. Okay? So the easiest one of these to use is the multiplication way. I use that one almost always. The only time I do not use that one is if I am given one of these. Okay? We are going to do an example using one of those just because I want us to see it and have an example done with it. But that most of these you should probably do that way. Okay? So we're going to go ahead and look at these tables. So Jerry takes the bus to school. Sometimes the bus leaves his stop on time, sometimes it leaves late. Even if the bus leaves on time, it can arrive at school late. Why would the bus leave on time but get there late? Traffic. A red light, a car accident. Who knows what happened? Okay? But then it says sometimes the bus leaves late and it still arrives at school on time. No traffic. Perfectly clear. It's like me on the mornings that I don't hit a single red light going down Schillinger, and it's great. That's a rare occurrence, so I think it's only happened once. But we can use the table to determine if leaving his stop on time, so we're looking at leaving his stop on time and arriving at school on time, are dependent or independent. So it will always explicitly tell you which two things you are checking for independence. Okay? It will always tell you. So what you're going to do first is you're going to assign one of them A and assign one of them B. Okay? So we're going to let A be leaving on time. And I'm going to let B be arriving on time. It doesn't matter which one you pick for what. I just always do whichever one it mentions first is A, whichever one it mentions second is B. Okay? And doing that helps, in writing it out, helps you to not accidentally mix up the order of them, so you accidentally miss something. Okay? Now, which equation do you want to use? First one or the second one? First one. So we're going to do the probability of A times the probability of B is equal to the probability of A and B. Okay, that's the formula we're using. Now, what is the total for this table down here? So what does that mean all of these already are? They're already written as our probabilities, right? We don't have to do any extra calculations for those. So what is the probability they arrive or they leave on time? 0.7. Okay, leave on time. Yep. Now what's the probability they arrive on time? Yep, 0.605. If it is already written with 3 decimal places, keep writing it with 3 decimal places and round to 2 at the very end, okay? Now, it is going to equal the probability of leaving on time and arriving on time. What is the one where it's leaving on time and arriving on time? 0.56. So, we need to take our calculators and multiply 0.7 times 0.605. What is it? So what are we going to say? 0.04 or is it 0.42? Equals 0.56. Is that true? Do those two things equal? Okay, so if it is not equal, it's not independent. So that means it is dependent.
Is our test going to be separated into parts again? Or
It will be one part, and the whole thing you can use a calculator on. And I feel like that's fine because for a lot of these questions, you don't actually have to do any calculating for sometimes. Like, if it asks you what's the probability of A, and this is your table, what's the probability of A? So, and last year my test was mostly multiple choice, I think. So I'm going to look at that and see if I can base everything off that test and just tweak it a little bit. We'll see though. But it should be a good chunk of it, multiple choice. All right. So now we're going to look at 13. Okay, for 13, it says you play 2 games at a school carnival. The first is a basketball toss and the second is a whack-a-mole. The table shows the probability that you will win each game. Are the events winning the basketball toss and winning whack-a-mole independent? So those are the 2 things we're looking at. So we're going to let A be winning in basketball toss. And we're going to let B be winning at whack-a-mole. And then for this one, we're going to use the second equation just so we've seen it before, okay? The probability of A is equal to the probability of A given B. Now, when we do this, that means we also have to find that conditional probability, which would be the probability of A and B divided by the probability of B. So that is actually what we're calculating right there at the bottom. So what is the probability of winning at basketball? 0.15. Okay, now what is the probability at winning at both basketball and whack-a-mole? What's the probability at winning whack-a-mole? Okay, so we have 0.15 equals what? It is. Do those two things equal?
Yes.
So what does that mean about it is independent? Because do your basketball skills have anything to do with your whack-a-mole skills?
No. I don't even know what that is. I mean.
Right? Probably not. Now, if it said a basketball toss and a ring toss, maybe. Because, like,
It's like
the-
a bunch of holes in the mouth and like a reverse thing.
and then you hit on me, yeah. And it's just like, whoop, whoop, whoop. Anyways. Now,
I played it one time too.
yes. All right. So both of these tables we've done so far had a total of 1 to start out. So it gave us all of our probabilities. If we look at number 14, does it already give us our probabilities? No. So as we set this up, we have to calculate them, okay? So for this one, we are looking at the events of taking Spanish class and not in marching band, okay? So A is going to be taking Spanish. And B is going to be not in marching band. Do y'all want to use after using both the first formula and the second one, which one do we want to do again? First one. Probability of A times the probability of B is equal to the probability of A and B. So remember, if on your test you at the very least write the correct formula, that is partial credit for that problem, okay? Even if you miss the actual probability question part of it, if you at least write the correct formula, I will give you partial credit. Like, set it up, okay? Now, what is the probability of taking Spanish class?
25.
Out of 40. Because remember, we have to put the probability. If it's not out of 1, we have to actually find it out of 1. Okay, times, what is the probability of not in marching band? Okay. Now, what is the probability of taking Spanish class and not in the marching band? All right. Now, to multiply fractions, you multiply straight across. So you do 25 times 17, 40 times 40. And then you would simplify the fraction. That is a lot of work. You get like 225 out of 1600 or something like that. Okay? Those are big numbers. Do you know what you can do when you have two fractions that you need to multiply? You can type them into a calculator and it'll spit it out and tell you what the answer is. Isn't that so great? Modern technology. Looky there. Okay? You have a tool that will help you on this. Use it. Okay? Now, what does that give us if we multiply those two fractions together? 17 over 64 is equal to 13 over 40. Can you simplify 13 over 40?
No.
So are those two things equal?
No.
So are they independent or dependent? Dependent. Dependent.
Hey, the office has been trying to reach you. Adams has an early school.
Nothing has happened. Hasn't rained either.
You're right.
That's so weird.
I'm sorry.
Oh, it's okay. I'm glad they got in touch. Bye, Connor. Oh, wait, Connor, come here. Okay. I'm giving this to everyone to go ahead and start. We're doing the odds together on Wednesday and Thursday because our test will be Thursday or Friday. So you'll have, because I made it extra long for extra practice because we've not practiced much. So you can start working on it. Okay. And shut the door, please. Thank you. Have a good weekend. All right. Now, we're going to go ahead and look at 15. Okay? So question 15. Our total here is what? 360. So that means I'm going to have to write the or can I just copy these numbers, or do I have to calculate probabilities? Calculate probabilities. All right. So for 15A, it asks you, are the events brings lunch and underclassmen independent? So let A be bring lunch. And B be underclassmen. Okay, for B, it asks about buying cafeteria lunch and upperclassmen. Okay, so let A be buy cafeteria lunch. And B be upperclassmen. Okay, you can use whatever formula you want to for independence, but I want you to decide whether or not those events are independent or dependent. Okay? On your own, please. Okay, for A, did y'all get independent or dependent? Independent. Okay. For B, independent or dependent? It is dependent. Okay, and that's what your calculation should be. Okay, so we are going to take a minute and we're going to talk about a couple things here for the rest of class. Not really all of class, but the rest of class, but like for a little bit. So I was out 2 days last week, right? So we are approximately 2-ish days behind that schedule over there. Okay. So on Monday, we are going to do probability lesson 5. Okay. Or Tuesday, we're going to do probability lesson 5. Okay. It's actually super, super easy. We kind of did it today when we did the activity where what happened when we take one out, leave it out, take another one out. And we're just going to learn how would we calculate the overall probability of all of those things happening in a row the way they did. But it's super easy. I like it. It's one of my favorite lessons in probability. But Tuesday, that is Tuesday. We're going to finish that. Wednesday, we are going to review the entire class period. Okay? Depending on what time we finish the probability 5 lesson, we may start reviewing on Tuesday. I'm not sure exactly yet. We're going to kind of play that by ear. Our test for the probability unit will either be on Thursday or on Friday. It just depends on how the pacing goes for everything, okay? But it will definitely be done by Friday of next week. So we have not had a big opportunity to practice, right? We've been working a lot, very repetitive work, but still we've been having to work a lot. So what I decided to do was I made the review longer, right? To give us more practice of the different types of things, right? So what I'm gonna do is I'm gonna go ahead and give this to you. We have to have this full review done, which is 52 questions, or 55 questions, okay, by our test day. I am going to try to go over all of the odds with you on Tuesday or Wednesday, okay? The rest of this you are responsible for completing and working on, okay? I tried to break it up so that way it covers basically everything we've done so far, okay? The only page you might not be able to do yet is the very, very last page of it, page 6, okay? Everything else you have seen before, but 5 and 6, we haven't really seen those yet. That's the stuff we will do on Monday, okay, or Tuesday. So, do we have any questions on that, what I just said? Right? I'm going to go ahead and pass these out. Don't lose them. We will have to turn them in. But that gives us plenty of time to complete those problems because I don't want you to feel like you don't have time to do all of the review questions. And if I wait to give it to you till Wednesday, you won't have time.
She's lying on me. It's reverse. I did what she said. Why would you say something like this? She did. That's nice of all to say. Wait, so when did it start of this stuff that we haven't done? Page 5.
5 and 6.
You give me a reason to love you.
We just simplified.
Why? You give me a reason to love you.
You're multiplying.
She just understands it, right? I should Yeah, we're writing it. So why are you saying big no? You give me a reason to love you.
That's cute, right?
I suffer from this.
Now I want to come into fraction. Not really, right? They're pretty big. So we just try to.
I love that.
That's where those languages are coming from.
You heard that?
Yeah.
Hey,
Let it go.
I want to free my mind.
you want to come sit with us?
Like Mario. The arsenal.
What's wrong with you?
I'll wait.
Hello? Oh.